Hello everyone, myself Nihal. So we have been asked by the ISE activity that we have to consider ourselves as an engineer to find out heat exchanger. So we have to make cost estimation and produce a heat exchanger for the given parameters. So basically we have to find out how a heat exchanger will work. So basically we have to consider AB as our roll number. So my roll number is 417. So considering 17 as AB. So we have to really first find out some critical parameters, that is inner diameter, outer diameter and length, and also cold inlet temperature. So first of all, for inner diameter, it is 12 plus 17 mod of 4 into 2, that becomes 14 mm. For outer diameter, that is 24 plus 17 mod of 3 into 2, that becomes 28 mm. And for the length it is 1.2 plus 17 mod of 5 into 0.2, that becomes 1.6 meter. And considering for cold inlet temperature, it is 20 plus 17 mod of 4 into 2, that becomes 100 degrees Celsius. So these parameters have been already given. We just have to consider it as according to inner diameter, outer diameter, length and cold inlet temperature. So moving next, we have find flow rates, that is hot flow rate and cold flow rate. For hot flow rate, we have value as 0.035 plus 2 into 0.005, which becomes 0.045 kilojoule per second. And as same for cold flow rate, some value have been changed, that is 0.05 plus 1 into 0.05, that becomes 0.050 kg per second. Later for heat transfer coefficient, it is given values, that is heat transfer coefficient for hot fluid, that is 900, and for cold it is 430. Output temperature, we have to assume the output temperature, that is I have assumed it is 50 degrees Celsius. And later for heat transfer, that is we have the formula, that is Q is equal to M into MC into Cp into T out minus T in. So we have the value that MC is equal to 0.05 into 4188, that is Cp, and T out is 50 and T in is 22. So 50 minus 22. So total heat transfer we get is 5860 watt. Moving up to next is heat capacity rate, that is CR. So basically to find out CR, we need to find out C minimum plus C maximum, that is capacity rate for minimum and capacity rate for maximum. So for capacity, for hot capacity, we have the formula of 0.045 to 0.500 as we have found it before. So it becomes 157.5 volt per kg, and for cold 0.05 into 4186, which becomes 209.3. So considering its ratio, that is for hot and cold, that becomes for minimum and maximum. So formula is CR is equal to C minimum divided by C maximum, which becomes 157.5 divided by 209.5, which becomes 0.75. So later it is effectiveness, as we know that effectiveness is equal to Q divided by C minimum into TH minus EC. So we have the formula for Q, that is 5860. And for C minimum, we are recently found 157.5 into 75 minus 22. 75 is TH and 22 is TC. So the effectiveness we have found is 0.70. Later on, the counter flow, as we know, counter flow is equal to efficiency is equal to 0 minus 70, which is the given data, and CR is 0 minus 75. So the overall approximate value of that chem is NTU is equal to 1.6. We have found this from standard relations. Coming up to next is LMTD. So basically the formula stands here is the same, that is Q is equal to M into MH into Cp into TH for inner and minus TH for outer. So we know that Q is equal to 5860. Next is M is equal to 0.045 and Cp is equal to 3500 into MH in is 75, and we have to find out T out. So basically the formula becomes T out is equal to TH out is equal to 37.8 degrees Celsius. For delta T1, we have 75 degree minus 50 degree, which stands for 25 degree. Later on the LMTD is here. T1 minus 15.8, that is T1 is equal to 25, 25 minus 15.8, and divided by E, that is 25 divided by 15.8. So LMTD becomes 20.1 degrees Celsius. So the overall heat transfer coefficient, So we know 1 upon U is equal to 1 upon 900 plus 1 divided by 430. So the basically U that becomes is 288 watt per meter square Kelvin. That is overall heat transfer coefficient. So we now have to find the required area, as we have to make a heat transfer heat exchanger. So we have to calculate, or we have to suggest a required area. So required area for we have to find is A is equal to Q divided by U into T delta T for inner. So the formula here becomes 5060 divided by 288 into 20.1. So the required area here is 1.01 meter square. So highlighting the required area, that is 1.01 meter square. Later on finding the area, total area, that is A is equal to pi dl. We all know that pi is equal to 3.14 plus diameter is 0.014 and L is equal to 1.6 as is given. So the total area becomes 0.70 meter square. That is not equal to our required area. So conclusion here stands that we have the area that is 0.7 meter square, 0.07 meter square, and we require the area is 1.01 meter square, that is more. So what improvements we can do, that is increase the pipe length. So by increasing the pipe length, the area will increase. We can use also fins. Later we can also increase heat transfer coefficient, that will increase the area. So for that, designing the heat exchanger, here is the cost estimation. For optimizing the cost, we will use the material of aluminum, that is inner and outer. So basically inner we will go around rupees 3000 per meter. So basically per meter means 1.6, that is 300 to 1.6 becomes 480 rupees, and for outer 350 rupees per meter, that will become 560 rupees. So total cost will stand for as 1040 rupees. Also for insulation we will require some amount of glass wool, so which stands for which is rupees 150. So adding it into the total cost, the final cost becomes rupees 1200. This is what cost estimation and my conclusion. Thank you.